This is not a concept, not a prototype, but a fully certified high-speed train built for national operation. Designed for sustained high-speed performance, the Al Boraq represents Morocco's entry into modern rail engineering.
Inside the factory, the Al Boraq is built and certified.
The foundation of Al Boraq begins with high-grade aluminum alloys and structural steel, meeting rigorous international railway standards. The underframe serves as the critical structural foundation, engineered to withstand immense dynamic loads at high speeds.
Automated robotic welding ensures structural uniformity and fatigue resistance across every critical joint of the chassis.
With the structural underframe and bogie geometry precisely aligned, the chassis is now verified for the integration of the main body shell. Massive hydraulic jigs hold the Al Boraq duplex railcar body in precise longitudinal alignment across its full length. Heavy-duty structural reinforcement presses exert constant downward force on the roof-to-wall interface, eliminating technical gaps. Continuous ultrasonic monitoring verifies the integrity of every rivet and weld across the massive double-deck assembly.
With the structural railcar body fully rigid and geometry verified, the assembly is now prepared for transition to the controlled surface treatment environment. The finishing phase begins with high-pressure surface preparation to ensure maximum coating adhesion for the high-speed rail environment.
With the protective and aesthetic coatings fully stabilized, the painted car body is ready for the integration of high-performance propulsion and interior systems.
The integration of high-performance traction motors defines the propulsion capability of the Al Boraq, requiring absolute mechanical precision. Advanced liquid cooling systems manage the thermal load of the high-voltage modules, ensuring operational reliability at peak power. Kilometers of high-voltage cabling are meticulously routed through the chassis, forming the central nervous system of the high-speed propulsion network. Integration of the traction motor and propulsion hardware concludes as precision monitoring systems verify torque alignment and electrical connectivity within the traction bay. Structural outfitting begins with the installation of high-density acoustic insulation layers to suppress vibration across the railcar body.
Precision mounting of the interior partitions ensures structural rigidity and optimized ergonomic spacing within the double-deck volume.
Thermal management and acoustic insulation are integrated as overhead interior modules close the railcar's HVAC and soundproofing layers.
With the core technical interior integrated, the railcar enters the final stage of interior outfitting before systems commissioning.
Precision integration of the driver console establishes the central command node for the Al Boraq's high-speed operations.
Standardized ERTMS interfaces provide the critical data link between the trackside signaling and the train's onboard computer.
Multi-layered safety protocols, including mechanical vigilance systems, are hardwired directly into the propulsion and braking control loops. Driver control systems and signaling interfaces are integrated at this stage, ensuring precise communication between the cockpit and onboard control architecture. The mating of the high-speed bogies to the railcar body represents the final major mechanical integration.
We're perfectly centered. We are perfectly centered. Confirmed. Ready for load transfer.
Structural dampers and primary suspension components are secured to mitigate lateral vibration and ensure stability at 320 kilometers per hour.
Automated sensors glide over the polished steel brake discs of the bogie wheel sets, verifying the pad-to-disc clearance after the full car body load has been transferred.
Aerodynamic side skirts are bolted to the lower railcar body, partially enclosing the bogie assembly to minimize air turbulence at operational speeds.
With the mechanical marriage complete, the vehicle undergoes a final series of structural and weighing audits before moving to the power-on and static testing phase.
High-voltage static testing begins with the verification of the vehicle's primary grounding circuits and safety insulation layers.
All green on the diagnostics.
Excellent. The integration is complete.
The integration of the main vacuum circuit breaker ensures rapid isolation of the traction power system during operational anomalies.
Thermal management systems are circulated under static conditions to verify coolant flow through the high-power traction modules.
Leakage current audits confirm that the metallic car body remains electrically isolated from the high-voltage circuits under static conditions.
Verification complete, zone clear. Roger that. Moving barriers now.
With all static high-voltage protocols successfully completed, the Al Boraq concludes its internal factory testing phase.
Dynamic stress testing commences on the specialized certification track to validate the Al Boraq's acceleration curves and structural resonance.
Aerodynamic sensors verify airflow stability during high-speed testing.
External noise emissions are monitored by acoustic sensor arrays to ensure compliance with international high-speed rail environmental standards.
The integration of onboard signaling and trackside balances is finalized through real-time communication tests at varying speeds.
Final delivery inspection formally verifies the Al Boraq against regulatory and operational standards.
From raw material to final certification, the Al Boraq is prepared for its official handover within the Moroccan rail program. Certified and delivered, the Al Boraq enters real-world operation on Morocco's high-speed rail network. NextGen Machine Works, building the impossible. Subscribe to join the future.